did we finish up? We started at number 3 last time to do the uniform distribution we talked about. Did we finish that?
No.
Number 3 yet? I don't think so.
We did A and B.
Yeah, okay. So just to remind you guys, well, I don't know if I want to mess with this. I'm going to let it slip. End up trying to make cheese. Anyway, draw the distribution. So we did this one last time.
Yes.
So nobody said they needed this, so I guess we were all here. So if you draw this, it goes from 1 to 12 minutes. Uniform, which means it's going to be the same height all the way across. Nobody has any more likelihood than the other thing. And of course, the whole point, one of the most important thing is what the height is going to be, because that's going to determine what the probabilities are, is how tall this thing is. And how tall was this thing? 111. Because the whole area, for this to make sense, for this to be a valid probability distribution, what 2 things have to happen for a valid probability distribution? It's going to be on the quiz on Monday. Yeah, so in general, the sum of the probabilities has to be 1, right? And the area being 1 means adding up all these probabilities is 1. That is the same thing. And of course, each probability has to be between. Probabilities have to be between what? What's the lowest the probability can be? And the highest it can be. So if I say verify this is a valid distribution, the probability distribution, check to make sure the sum of the probabilities is 1 or close to it, and check to make sure they're all between 0 and 1. Are you guys with me? Did I tell you what I'm going to do to you on the test? Anybody remember? The sum of the probabilities on the test will not be 1. You guys remember that?
Yeah.
Sounds like a great note to take, because I'm telling you what's going to be on the test. Yeah. All right. It's going to be like 0.9999 or 1.0001 or something. Why is that okay?
Because it's close enough.
Because it's close enough. And why is it off? Because of rounding, right? We know that when you round, we've seen it happen when we made relative frequency distributions before. It didn't come out to be 1. We didn't go, holy shit, that's the end of the world. Okay, maybe. We normally don't do that. Holy shit, it's the end of the world. All right. So, then any question, once I've got reality set up, here's reality. I just worked within it. Any probability question is equal to the area I see for that question. That is so desperately nice. It is exactly that thing about the bullseye and the dartboard. We have an intuitive grasp of this. We're just trying to formalize it now. So if I draw this, let me draw it again. Here's reality. We're 7 and 11, so 7's like right here, 11's like right there. What's the area of that rectangle going to be? How wide is it? 4? I'm right next to this dumb thing. I can't hear anything. 4. How tall is it?
111.
So the area would be 1/11 times 4. 4/11ths, which is a beautiful number. Right? 3, 6 forever. You guys with me? You gotta let chapter 5 be nice. It's trying to be nice. It's doing all I can. So try part C if you haven't done part C yet. Monsieur Quitsi? Alessandro? Emerly? Anybody else not get there? Who's back? Oh yeah. I'll let you know when we get that made. So one little thing you gotta be careful about, first 5 minutes, which part of that doesn't mean shit for this situation? 0 to 1. So first 5 minutes goes up to 5, and then I just find the area that I make. So first 5 minutes, so up to 5. So I'm looking for the area of this, because this gives me nothing. The area out there is 0.
So it's the same as the other.
Same as that one, yeah. Right? Nothing amazing, but it doesn't mean shit. It's just the same probability, right? Because it'll be 4 width times 1/11 height, 4/11ths, which is still 3636. That's crazy. Okay. What's this? Yeah, it's the same thing as what's probably takes me less than a minute. 0 for this situation. What's probably takes me more than 12 minutes. 0. Because after 12 minutes, I just stopped looking and stayed where I am. You guys see that? Is that right? The only place that gets any probability is from 1 to 12. Anything outside of there gives you nothing. There's no chance of that happening. Most probably we find a dude that's 28 feet tall. 0. If he existed, we would probably know. Although I don't know. You guys have conspiracy theories on he's reptilian, shapeshifter. Alright. So that's 0 for damn sure, because there's no probability out there. It doesn't give me anything. What's the probability now? I think we talked about this. I don't know if you guys remember that word I said. I did talk about that, right? That weird Greek word. Did I say? Iota? Yes, maybe. I know it sounds like I'm saying iota. It's IOTA. So what's the probability that X is exactly 8? 0. And I really want you to understand this. What's the probability that I find a man who is exactly 5 foot 9 inches tall? Exactly 5 foot 9. No matter how carefully I measure this dude, it's 5 foot 9 inches, 0, 0, 0, 0, 0 forever. What's the probability of that? 0. I don't know if that helped at all. Some of us, we don't see that. And again, now watch this. Another way to think about this is, how many numbers are in here? How many numbers? No, come on. How many numbers are from 1 to 12? No, come on. And you're like, what do you want from me? I didn't say integers. I said numbers.
Oh, it's too many.
Not just too many.
Because it's like...
Infinite number of numbers. You guys with? Because I'm counting 0.5 and maybe 0.512. Well, not there. Sorry. 1.5. 1.512. 1.6987777777773. All right. Are you guys with me? So how many options? What would be in the denominator if we try to make this a normal probability? There would be infinity. And I want one thing out of that. That's 0, right? Maybe. I love the way you're looking at it. So just remember, now here's the most basic way, and this is what I said last time. All this iota shit, infinity shit, if you don't like it, okay. What's the answer to a uniform probability question? It's related to the area you make, and when you draw a line, you have made no area. That's simple. The area is 0, so the probability is 0. Yes? Maybe? If I draw a line, 1/12, I want the probability of 8. What's the area of that? Well, what's the width of that line? It goes from 8 to 8. What's the width? 0 is dead. No area. 0 area, so 0 probability. Yes, yes, yes? That's the most basic way to think of it. Okay, I like it. So let chapter 5 be simple. I will mention this. Let's see if you guys can handle this. There are 2 things in chapter, there they are, in chapter 5 that you must do for the homework, but I will actually not test you on. And those 2 things, so I can make this blank space. Let's see how tiny I can write. Those 2 things. What's the 2 most important things to calculate for any distribution we get? Anytime we got a new distribution, we got the XP of X shit. What did we figure out? We got binomial. We got the probability, but then we figured out how to get the 2 things, the 2 most important things to calculate. The mean and the standard deviation, right? Well, I want to know where the center looks to be, and I want to know how spread out it seems to be. Yes? Those are the 2 most important summaries of any set of data or any distribution. So we have a uniform distribution. What's the mean and the standard deviation? So here's what they come out to be. Now this hopefully makes some sense. For the distribution from 1 to 12, and they're all equally likely, so what's the average amount of time it would take me? How would you figure that out? Anywhere from 1 to 12, so what's the average going to be? How would you figure it out? No. I understand what you're saying, 6. It's not 6 though. Just find the average of 1 and 12. Get the middle. Right? Say again? Not minus. How do you find an average? Add them up. 12 plus 1 divided by 2. So, for a uniform curve, those 2 numbers, 1 to 12, 0 to 15, whatever the hell we're working with, are called A and B. So the formula for the mean of a uniform distribution is A plus B divided by 2, just the middle. They're all equally likely, so the average is going to be in the middle. If you roll a die 80 billion times and you added up the numbers you see and divided by 80 billion, what's the average you would expect? Roll a die. You get a 1, you get a 5, you get a 4, you get a 3, you get a 6, you get a 1, you get a 6. What would the average be if you averaged all those up? Did you guess? If you rolled a die, what could show up? 1, 2, 3, 4, 5, 6, yes?
Yeah, 6 numbers.
So if you rolled it a lot and then you took the average of the numbers you see, what would that average be? If the average was 1, that would mean you got nothing but 1s. Do you see that? The minute you get a 2, the average is going to be higher than 1. If the average was 6, that means you got nothing but 6s. So if I roll a die, a normal die, what should happen most often? I get a mixture of 4, 5, 6, and 1, 2, 3, right? So maybe. So what would the average be? 3.5. Because for as many 1s you get, you would expect to get as many 6s. For as many 2s, you would expect to get as many 4s. And for as, right? For as many, where am I at? 2s, 5s, 3s, 4s. There it is, Jeff. Maybe? No, you didn't like that example? No. Shit. I don't know what else to do.
Why is 3.5 and not 3?
All right.
If it is 6 numbers.
It's 6 numbers. So for each of these, you'd expect to get... Does that kind of make sense? I'm not saying that's going to happen, but if you rolled it a lot of times, I would expect about as many 6s as 1s, wouldn't I? In fact, to be really honest, you'd expect about the same of each one, wouldn't you? Would there be any reason any of them would show up more often than another one? If it's a normal die. Stay with me now. If you roll a die, would you just go, I think 2's going to show up more? Why would that be true?
Yeah, it would be equally ish.
Yeah, so not ish, right? The probability is exactly the same. Come on. So for every ones, I would expect the same number of sixes. For every twos, the same number of fives. For every three, the same number of fours. So the average will be 3.5. Yes, which is 1 plus 6 divided by 2.
Okay.
So this is a very, very basic form of a uniform distribution because they all show up, they're all equally likely. 1, 2, 3, 4, 5, 6. It's not continuous though, that's why it's not exactly. Okay, I don't know. Okay, maybe. All right, so that formula is nice. You're really going to love this shit. This one I can't. This one I can. I can show you why this is the way it is. If you want me to, I can show you. I've got a little thing I've put together because I had a whole class that was, let's see what you guys say. Here's the standard deviation. What's your first reaction to that? That's an A, by the way, right? My A's look like 9s. Anybody have a first reaction? That's the standard deviation. It makes sense as a square root. It kind of makes sense as a square, right? We've seen that happen in every square root standard deviation we've done. Anybody have anything to say about that formula?
That's 12.
Beautiful. Yes, exact. Thank you. Right? If you ever anybody watch Doctor Who, it's like he's waiting for somebody to say it's bigger on the inside. I could show you that if you want to. So if you want to see that, you can email me or come to my office and I can print you out the proof. It does involve calculus, just to let you know. So if you don't know calculus, you can stare at it, but I don't know how much you get out of it. The 12 doesn't make any sense, but that's because we didn't see all the steps to get here. You guys with me? But now it's just a plug and chug, right? So there are some homework problems that ask you these. Why? Oh, it's the jackass. All right. So if I had a distribution that went from 3 to 7, what's A, what's B? Yeah, A is 3, B is 7. Could you figure out these two things? Shit, yeah, you just throw in 7 for B and 3 for A, right? So on that level, I wanted you to do some homework and realize any distribution I get, I need to know how to get these. I've said that before. But these are really not very often used. So I'm not going to really test you on it, but I do want you to use these. They're not hard to use. Just plug in the B and the A. Yes, maybe? Okay, enough of that. Okay. Let's see. Okay, so we got that done. I love it. Let me make sure one more time. Everybody's got this, right? This thing we were just working on. Because we're going to finish up the top of this. On the one side, it's got this bad boy, right? All right. I don't think we did any of the top of this. Is that correct?
Mm-hmm.
So let's do that. This is going to be a good review for that quiz we're going to have on Monday. Go ahead and try to do the first couple if you haven't done those already. If you have done them, just, hang out. Wait. Does it feel all right in here? You guys want more heat, or are you guys okay? Bless you. Thanks. I don't want any more heat, so if you guys don't say anything, I'm not going to give us more heat. All right. make sure everybody's on the right track. And somebody tell me what n is for this first problem.
22.
22. I love it. We're working with 22 people. N always means the same thing. Thank God. What's P going to be in this case?
0.68.
Yes, 0.68. So then what's Q got to be?
0.32.
Yeah, where'd you get that from?
1 minus.
Yeah, so P and Q always have to add to be 1 because they're opposites of each other. Please make sure that they do add to be 1 when you do a problem, right? Before you start doing stuff. And in this case, what's X going to be for the first problem, for part A?
13.
We put it over here. I like it. All right, so then how does that formula get set up? It'll be
0.
who?
0?
How many people I got?
22.
22. And I want to choose how many to be successes? 13. So how many successes do I have? 13. It's a little repetitive. I appreciate that, right? Got 22 people. Okay, I want 13 to succeed. Well, how many successes? Freaking 13. I have no idea. I got two guys talking to each other about probability in my head. Oh. And then, so how many failures you got then?
9.
Must be 9. Right? Where the hell did she get that from? You guys see that? There are 22 people. If 13 of them are here, the other 9 have to be over there. I really want you guys to start understanding that almost every formula you see has to have some directly physical or somewhat physical interpretation. You have to be able to kind of see the story behind it. And this one is really kind of in your face with the story. I didn't bring my calculator, so hopefully, I don't know if you guys have calculators. I have my one calculator. So if you plug this in the calculator, it's going to look like this: 22, math, which part of this? Probability. Number 3 for choose. 22, choose, I forgot already, 13. Hit the over arrow to get back up. Times 0.68, I want 13 of those. Hit the over arrow to come back down. Times 0.32, and I want the rest to be that. Boop. So what you guys get?
Yeah.
Yes? Okay, I like it. 1163. No. Everybody, you guys, what do you guys think about part B? I haven't given you much room there, have I? And somehow I'm saying you should be able to fit it in there. What's less than 21 mean? If you just turned 21, you should know this really well. What's less than 21? 20. 19. 18. So if you want to do that problem directly, you'd have to do the formula we just did for 20, 19, 18, 17, 16. All the way down. We did 9 already. Yay! 8, 7, 6, all the way down to 0. Holy shit. So what do I do when I'm given a probability question that seems to have way too much work? It's unreasonable, the amount of work. You don't go, damn you, Jeff. You think about what the opposite is. What does less than 21 leave out? 22 and 21, right? Yes? Mm-hmm. Less than 21 does not include 21, correct? Mm-hmm. So if I figure out what's the probability of 21 or 22, I then just have to do 1 minus that. If I figure out the opposite question and piss the questioner off, I didn't ask you that. Do 1 minus, we got his answer, right? Maybe? Okay, so it's not just at least one. At least one is the most common example of what I just said. It's always there, because probabilities always work that way. Two opposites. 1 minus 1 is the other one probability, right? Always, always. So anytime you're like, holy shit, I don't want to do all that, don't. Do the opposite and 1 minus. Now, if the opposite has about the same amount of work or more, then screw the opposite. Just do it directly. Yes? If I said probably less than 4, that's 3, 2, 1, 0. The opposite is 4 up to 22. Screw the opposite. Do you understand what I'm saying? So I'm not saying always do the opposite. Somebody always hears me say that. Like, I never said that. Do it if there's less work. That makes general sense. There's a life lesson for us, kids. All right. Kids, Jeff, roll. So if I figure out what the probability of 21 or 22 is, I just have to do 1 minus that to actually answer the question. So do the formula for 21. Do the formula for 22. Add those up, because it's or. And then subtract from 1, because that would be the opposite of what it wants. So if it's subtract from 1. Gather. Right, so do the formula for 21, do the formula for 22. You can actually throw in the calculator exactly like this. Right? Just throw all this shit in there at once, so you don't see any intermediate decimal stuff. Alright, let's see what you guys get. So 1 minus, where could I put this? Scheiße. Alright. Oh, Jeff, what just happened? Oh, yeah. Okay. Alright. Anybody get what these are yet? Added together?
10023.
Good. So if you do this plus this, you get 0.0023. That is the answer to the opposite question. So then I just do 1 minus that to answer the question. I only had to do 2 formulas instead of 20-something formulas. Right? Damn straight. I don't know if you guys remember my shortcut for doing this. 9, 9, 7, 7. So almost 100% chance that less than 21 of these people think whatever the point was. I forgot what the think that, campus climate prevents people from speaking freely. By the way, I didn't put the link, but this actually does come from a study. I normally put the link on there, but oh well. I don't know how you guys feel about that. Yeah, Jeff doesn't let me talk more shit. All right, so any questions on those 2? So try out number 2. Go for it. I'll let you guys do it all the way through. Call me over if you need some help. You can check your answer.